So here with me today, we have Mike Boudreaux. He is the Director of Connected Services at Emerson, and Andy Rhodes, the Vice President and General Manager of IoT at Dell. Today we're going to talk about a use case, a partnership between Emerson and Dell. It's an equipment monitoring use case. And before we go into it, if Mike, you want to kind of talk about the importance of equipment monitoring.
Sure, yeah, thanks. For those of you who aren't familiar with Emerson, we're headquartered up in Round Rock as our facility for our process systems and solutions business, and we're actually right across 35 from Dell, which makes it easy for us to partner and to work on fun things like industrial Internet of Things. I'm focused on developing connected services where we collect rich sensor information from critical process equipment and refining chemicals, life sciences, oil and gas facilities, get that into the cloud, put it in the hands of experts, deploy analytics on it, and then deliver actionable information for our customers related to performance improvements and reliability improvements for their process. The real opportunity for industrial Internet of Things for Emerson and our customers is to solve some long-standing problems they've had related to improving the reliability and performance of their operations. In fact, people are throwing out trillions and billions of numbers of sensors and connected equipment and products and so on. We look at it from the business side, and we're focused on helping our customers move from lower tier performers to top quartile performers whenever it comes to reliability and performance of their process. And we see an opportunity in the industry to save, there's about $1 trillion worth of unnecessary cost related to suboptimal performance that we can help them improve in a variety of ways, one of which is providing connected services. And that's right in the core of the whole industrial Internet of Things concept, where there's lots of sensors already installed on the equipment. There's new innovative sensors that we can add to the infrastructure. And the opportunity now is, instead of selling our customers products and technology that may be too complex for them to do themselves, now we can deploy sensor networks and connectivity securely to the cloud, and then get that into the hands of our experts as well as to deploy analytics. So that's the big opportunity that we see. It's not just about the technology, it's about new business models and really putting experts to task at getting the value out of the data.
Yeah, absolutely. So we're gonna talk about the partnership between Dell and Emerson, but first I want to throw out some more numbers provided by Dell. ARC Advisory Group reported $20 billion or 5% of annual production, and the global process industry is lost because of downtime and poor quality, and 80% of that is preventable. So we now see just how important it is, and Mike, we're going to start with you. This is kind of this is Emerson's deployment. Can you talk about the pieces of it?
Sure. There's actually a lot of different reference architectures, and we have to be flexible to integrate secure connectivity into our customers' networks and equipment, and they have a lot of different technology that's already installed. Emerson has a long history of supplying what we call OT, operations technology, sensors, transmitters, measurement technologies, control systems, and control devices. And that has, a certain type of security model and reliability model and technology model that we're really good at. For us to connect that type of system to the cloud, we need to now connect securely through IT systems. And that's where Dell's strength is. So, the opportunity for us to work with Dell is to bridge the secure operations technology environments through IT networks and into the cloud, and to leverage our common strengths. And there's no one company that can do it all. So partnering with companies like Dell and others, in fact, we're partnering with Microsoft and OSIsoft, if you're familiar with them, on a solution that we can talk about here, that helps us to get that data securely into the cloud.
Certainly. And Andy, can you talk about where Dell is? What are Dell's strengths in this use case?
Yeah, no, absolutely. So if I back up a little bit, when I think about IoT, that's a big buzzword in the industry right now. We break it down into real life use cases, and so we rather talk about predictive maintenance or monitoring of high value assets, or cold supply chain, or building management, or traffic management, and then it sort of makes it real for everyone. The underlying principles of gathering data off things, because we talk about sensors a lot, but a thing could be a truck, it could be a light bulb, it could be a sensor, is the common thread, and then analyzing that data for some sort of business gain is the other major thread. And we sort of break the business impact down into 4 major buckets. The first big bucket is driving efficiencies in whatever process you're trying to automate or orchestrate. And so that could be, I've got a factory and I'm trying to make my yield of my factory higher, or I've got a fleet of trucks. If you're FedEx and you have 250,000, 300,000 trucks, how do I save 15% fuel on those trucks? The second big business value that we see is safety. How do I make my process safer? The third is around customer experience, and the one I love here is if you look at the hotel room of the future, they're going to use a lot of IoT type technology to allow you to avoid receptions. Your phone will be your key. As you go towards your hotel room, it will know that you're coming to the hotel room because of your GPS. Sort of scary, I know, but it's all in your best interest. And then as you walk through the hotel, you're checked in automatically. You walk up to your room. You use your phone to open your door, and when you get there, your online profile, has told the hotel exactly how you like that hotel room set, the lighting, the temperature, the music and the ambience, and what TV station you want. So that's about customer experience. And then the third, and where it gets really exciting, is net new revenue streams or net new business models. And we all know the examples of Uber and Airbnb, but you look at things like the elevator companies today, and if you ask them what business they're in right now, they're in the business of making steel cages that move people up and down buildings. And in the future, they'll be in the business of, providing rides per floor per person. And then because they own the contents of the elevators, i.e. us, they're going to offer digital signage in the elevators, and they're going to move to revenue streams around advertising, right? So that's a really exciting thing about disruptive technology. All of that requires, I think Mike put it eloquently, a connection between the operations technology people, what we call OT, and IT. Because now you have lots of different silos of data converging together, and the people in the corporations that we serve today that own data and analyze data is the IT department. And so Dell's role here is we sort of connect to OT with our IoT gateways. We have all of the I/O and the protocol connections in sort of the operations technology world. And then we allow IT to manage the data on top of that. So, what we're doing with Emerson is helping them with the IT pieces, one, in connecting the things that they have, and then two, by allowing IT to feel really comfortable with the traffic now that goes through the IP network.
And what are some of the industries you would see a use case like this in, using both Emerson and Dell's solutions?
Yeah, well, the industry applications that we're focused on right now are primarily refining, chemicals, oil and gas type applications, where they have really critical equipment. Performance improvements and reliability improvements can deliver really significant savings, increase their throughput by preventing unplanned shutdowns, and enable them to do more planned predictive maintenance and actually lower their maintenance costs by performing maintenance in a more planned, proactive way. So that's really the focus area on solutions like control valve monitoring, pumps, compressors, heat exchangers, that type of critical equipment, so that our customers can make better decisions about how they maintain and operate that equipment.
I also think there's really good monitoring of high value assets. Is it broken? Is it on? Is it not? That's all about uptime. We have a lot of customers as well that want to move to this whole notion of predictive maintenance. Right now, you'd be surprised how many people still put people in trucks, drive to high value equipment, visibly inspect it on a time sequence basis, no matter what. Every 6 weeks, I'm going to go out, I'm going to go look at it, I'm going to inspect it, whether it's broken or not. And if you're operating machinery around the world in West Texas, or a lot of our customers, West Texas is a dream because you can actually put someone in a truck and go and visit that plant. But if you have a dam in Peru, or you're operating a mine in Kalgoorlie, Australia, the cost of sending people out to those places is massive, and it eats into the bottom line of many of our companies. By orchestrating those expensive things, by monitoring them and then looking at the algorithms of when things break and why, you can then send people out at the right time with the right parts on the right schedule and save a huge amount of bottom line savings. And so we have a lot of customers, and I think Emerson is really a leader in this space and actually putting it together rather than talking about it. But I think that there's a huge amount of bottom line savings there just from maintenance avoidance as well as uptime.
Yeah. Absolutely. I mean, what you just described is spot on for a lot of the opportunities that we have. And it's about improving the efficiency of our people, the effectiveness of them. And a lot of times we're sending experts traditionally out to the equipment. So they're spending time in front of windshields on planes rather than doing high value work. And our customers don't want to wait for days for somebody to come out and fix a problem. And they sure don't want one of the service techs to show up and not be prepared with the right equipment or parts, right? So for us to remotely collect information, sometimes remotely fix problems, and then to proactively and in a preventative maintenance-based approach, go out and do work on the equipment before it fails. There's tremendous savings to be had there. And our customers will receive a higher level of service from Emerson, which makes them happy too, right?
Yep, and Andy, we talked about this. You provide the gateways, and then another place the data will go is up to the cloud. I know that Microsoft's Azure is part of this use case. Can you talk a little bit about edge computing and sort of the importance of it and how it differs from, or when you would want to use it?
Yeah, absolutely. I think there's this whole notion that we're all sort of trained in this consumer-esque mindset. So we think a lot about IoT being a Fitbit. I mean, I'm sure you guys here being in the industrial side don't, but when I talk about IoT a lot, people are like, yeah, I get that, it's Fitbit, and all of the data goes from the thing to the cloud. And that's a very consumer-esque model. And so there's never, the first thing I say is there's never one right or wrong IT architecture for IoT. But backhauling, if we have 50 billion things, 100 billion things, I don't know, I think analysts are competing with the billions of things, But if we have all of those connected over the next 10 years, and I'd sort of say most of them are already sort of well connected today, and you think about backhauling all of that data into a Microsoft cloud or an Amazon cloud, or even our customers' own data centers, we don't have the network bandwidth in the world to do that. And a huge amount of that data is actually not that useful in its raw form. And so where edge computing comes in is the first task is connect the unconnected. A lot of this stuff doesn't natively connect to the internet. It's not wireless, it's old, or it's these sort of very industrial protocols. So the first task of the gateway is actually provide a connection to multiple different things without having to build a custom product every time, because we see a lot of custom building happening, and that really drives up price and lowers quality because just the dynamics of having to do custom every time. And then the second is this: once you do analytics at the edge, you can send less data across the networks, or you need real-time answers. And so sending a round trip of lots of data to a network across the world to a cloud, wherever it is, and back, sometimes the latency isn't there. Or in many cases, the connectivity isn't there, Or the third is that customers are so concerned about security of the data that they've got to keep it on premise and on the side. So, the best example I have is a customer of ours, another customer, and they use a Bosch sensor, and it has about 20 different attributes on that sensor: temperature, humidity, accelerometer, gyroscope. And if you leave that sensor on the table and static, it creates 9,600 data points a minute. And if you visualize that data when it's sitting on a desk, it's just flatlining. It doesn't look like anything's happening, but still 9,600 data points a minute. You pick the sensor up and you hold it and you shake it and you visualize it, and accelerometer's going all over the place, temperature starts rising, and you put it back down, it's still 9,600 data points a minute. If you then stored that perpetually in the Amazon cloud, it would cost you about $1,000 a month to do that. And if you're running a production line and you're really looking at, say, vibration or temperature on the production line, you probably have 20 or 30 of these. You're looking at thousands and thousands of dollars of data storage in a perpetual public cloud. And really what you care about is, I only care if things go out of a certain variance on the production line. And that's where a gateway would come in. It's sort of analyzing that data constantly. It's filtering it, throwing it away, or compressing the data, and then doing something with it when it needs to. And so that's where edge analytics comes in. It's either speed or cost or connectivity, or in many cases, all three of those. And that's where Dell does everything from the gateway through to the back-end data center. We have assets now with the EMC merger like Pivotal, where you can build cloud-native apps at the back end. But we're sort of agnostic of what that architecture is. Our customers really define how much analytics they need to do at the edge.
Yeah, to add to what Andy was describing, whenever we're developing the connectivity model and the data model for what we send to the cloud and what we don't, we really have three basic modes of data transport. The first is there's dynamic parameters that we know that we want to collect at a set high frequency, where high frequency could be once a minute.
Yeah.
In this space, right? It's not necessarily once a second or once a millisecond for real-time control. These are monitoring type applications.
Yeah.
So once a minute is actually pretty fast. So we'll collect that data and stream that to the cloud. So then we can do time series analysis and analytics on that data. If we need higher fidelity data, then we'll increase the data rate, but generally that's pretty fast. There's also data where we know that we can do richer diagnostic type of routines on equipment and collect really, really high fidelity data. Super high fidelity data, like a vibration waveform, for example. And we'll do that on a routine scheduled frequency. That could be once a week, once a month even, and that's typically sufficient if you're doing condition monitoring on rotating equipment, because mechanical failures don't generally happen overnight. And then the third type of mode is where if we detect an event, so we'll have algorithms running on the edge, kind of a, if on event, then collect this set of data, right?
Exactly.
And that'll trigger diagnostic data that we capture and send to the cloud. Those are the three basic models that we have right now. There's always variations, but those generally cover most of the ground that you need.
Yeah, absolutely.
What's interesting though, when you get into the industrial side, and this whole notion of IT meets OT, right, is Dell's known for creating products that either sit in a data center, which is a massively controlled, cooled, clean environment, or on a desk or under a desk. And through working with Emerson and others, we realized that the difference with a gateway in an industrial setting is it's sitting in what I call in the wild, right? It's in places that you don't expect to see IT equipment, and that's where understanding both of these worlds is really, really important, because Mike's customers probably are operating from -30 to 70 degrees C, and they're in these environments where you can't get a tech out in hours, so there has to be massively robust. And so if you look at our gateways, these are big chunks of of steel that are designed to operate flawlessly in the type of dirty environments that Emerson works in.
Yep. So I want to take a step back, and I want to talk about if there's one common thread I've seen in IoT, it's that companies are coming together to solve these problems. I like to think of IoT, it's like one big, really complex puzzle, and everyone has a different shaped piece, and we're slowly seeing these pieces come together and work together. So if each of you would like to talk about partnerships and their importance in IoT.
Sure, yeah. It's a good point. You can't do it all on your own. And there's a solution brief that we collaborated with Microsoft, Dell, OSIsoft, and Emerson. In fact, we were demonstrating this at Dell EMC World last month, and then also at Emerson's user event here in Austin called Emerson Exchange. And that type of reference architecture has industrial wireless measurements talking over an industrial wireless mesh network protocol called Wireless Heart. And so we can have temperature, pressure, flow, acoustic, vibration measurements all communicating to a wireless gateway, which is all built on this OT type of paradigm. You can install it out in a refinery where you have hazardous hydrocarbon-based environments. That connectivity is then connected to the Dell Edge Gateway, where we were hosting an OSI Pi historian database. That database can collect all of that time series data, and then OSI Soft, who's one of our partners, provided the connectivity through a Pi Cloud Connect service that they have, and then we were hosting a Pi database in the Microsoft Azure virtual machine. All of this, and by the way, we also had what we call Plant Web Advisor apps, which were tightly integrated with Pi for energy, reliability, and performance monitoring. All of those are tightly integrated together. What's really important to recognize here, the gentleman was talking about doing IoT for 30 years. We've been doing a lot of this for a long time, okay? All of this is commercial, off the shelf, ready to buy, ready to implement product. It's fully tested for 24/7/365 use, and it connects together extremely easily and extremely well. So doing that type of architecture, and this is something that customers are asking us for right now, is something that we can deploy, and it's not a test bed, it's not a proof of concept, it's not a lab type of application. This is something that we can deliver today based on proven technology, and it's about integrating the right pieces together to actually make it work, and most importantly, to deliver the value to the customer, which is about improving their energy, their reliability, performance, giving them better visibility into the health of their equipment.
Yep. And Andy, I know Dell has its own partnership program.
Yeah, I say this repeatedly, that anyone that says they do it all is either deluded or a liar. Probably more deluded than anything else. And here's why. It comes back to my statement that the IoT is a theme. It's a set of use cases. And so you have to have people that have domain knowledge in the use case, experts in supply chain or cold supply chain, experts in industrial, experts in building management, experts. So you have to have all of this domain knowledge as one factor. And then on the IT side, on the IT infrastructure side, you've got people that make the things themselves. Dell doesn't do that. We didn't wake up one day and say, hey, in IoT, we're going to connect smart lighting with smart refrigerators and HVAC systems, so we're going to become a light manufacturer and compete with GE Lighting. But on the IT, even on the IT infrastructure side of it all, you've got hardware like gateways and servers and networks. You've got wireless networking. You've got low-powered, all the new low-powered stuff. You've got all of the analytics platforms. You've got all of the visualization platforms for the data. So it takes a village to bring it all together. And I think a lot of companies are starting to take a good hard look and ask themselves, what business are we in? What are we really good at? And it was very clear to Dell. We're great at the IT infrastructure, hardware, software, the operating system level, security, systems management, big data analytics through partnerships. And so we build out this partner network to then help people like Mike not have to fit it all the, as you said, the Tetris pieces together. We do a lot of that on the IT side, so he really has to focus on his customers and adding the value that Emerson does, which is really a lot of that domain knowledge of how do pumps operate, how do valves operate. So I think it requires a bunch of domain knowledge or OT knowledge, and it requires a lot of IT companies coming together. And then the quicker we can make these blueprints really relevant, and show people how to do predictive maintenance, show people how to do cold supply chain, so that everyone's not starting from scratch every time, then the quicker the market's going to take off. So yeah, so partnerships are a key play. And I think there's probably way too many players in the space today. I mean, I was with an analyst the other day, and she was tracking 450 IoT software platforms. Well, I can tell you the world doesn't need 451, so we didn't go off and do one at Dell. It probably doesn't need 450, but it's not 3 because of the domain expertise. You look at what OSI Soft does. very different than what Microsoft does, very different than what Dell does.
Yeah. Before I go on to questions, I'll ask probably the most difficult question and ask that you answer it in a short amount of time. Sure. So maybe that'll spur some more questions on. But what do you see as the biggest challenge you face in IoT, and how are you looking to overcome it?
Oh yeah, well that's an easy one. There's actually two answers, but I'll keep it short. Generally, we've surveyed our customers on this, and we've also seen industry surveys. The two most important challenges that come up every time are security and the business case. Mm-hmm. And the security one kind of is you have to have security, right? And there's models and ways to implement the right level of security. What's happening in the more consumer IoT space isn't really helping too much, because there's a lot of fear that's starting to happen with connected products that aren't built inherently secure. Mm-hmm. In the OT space, we've been embedding security in these systems for quite a while, and we're not going to go about things without the right level of security controls in place. In one survey I saw, the business case actually came up first on the list. And that's one of the things that people are struggling with, is they want to deploy this new technology. They see the potential value in it, but actually identifying, the business case for investment in the infrastructure and the connectivity that's required is a stumbling block. And what Emerson's been doing to help, get over that hurdle is actually focusing on very specific industry problems related to energy reliability and performance improvements that we can help our customers address. And we will actually build cash flow analysis spreadsheets for our customers, and we'll build the business case and work with them to collaborate to build that investment. The other thing is, rather than just sell the technology and the products on a CapEx, capital expense type of budget, we're developing new innovative business models where we'll provide everything as a service. So we'll provide the sensors, the wireless networks, the cloud connectivity, the software in the cloud, and we're just providing actionable information as a service on a monthly subscription fee. And that enables our customers, in some industries right now they're capital constrained, but they have OpEx budgets, and if they can turn that into a cash flow type of conversation, then they're able to sign up for these long-term service agreements and justify it that way. And we're developing flexible business models to help our customers with the business case problem, which, if you're really technology focused, a lot of times people overlook that, and a lot of our customers are engineers. I'm an engineer, and working through the real business case and the justification can be a real challenge.
Very interesting.
Yeah.
And Andy, on
I think Mike nailed it, and we've talked about this a lot over the last month. So security is still number one, and my response is always, remain paranoid but not paralyzed, because your competitors are going to go do it, and then you're playing fast catch up. So that's definitely one. I agree more and more that the technology is the easy part, quote unquote. What we find is a lot of the projects stall because inside of the companies we sell to, no one knows who's on point, right? And often the person deploying the solution isn't the person getting the business benefit from the solution. And then you have this notion of, everything's going great, and then IT gets involved and slows it all down, or everything's great, but you can't get the CFO on board because you're buying in a different way. So I think it's a lot more about the interpersonal, organization relationships inside companies and how to go make it happen than it is about the technology. I mean, that's I wouldn't say it's easy, but it's been solved many times, not just by Dell and others, but by the whole industry. What's not been talked about enough and not been discussed is, how do you bring organizations and different functions within organizations together to go, break down these hurdles and get one of these projects implemented.
Yeah,
that's I think the biggest. We've experienced that. Just if you think about the new channels to market, the new your customer is a different customer than it was before. So all those things have to be considered way up front in the project, not at the back end when the tech is done.
Yeah, very interesting.
There's a lot more stakeholders to manage.
Yeah, that's true.
Yeah.
Yeah.
Great. Well, thank you very much for speaking with me. And we're going to open it up to questions. I'm sure they're... Yes? Yeah.
On the refinery and side of things, could you give us an example of maybe what one of those really looks like in terms of the number of sensors, gateways, data collected, and what was the process the customer went through to actually make a decision and implement?
Sure. So one example I could share with you is in a refinery, we're monitoring control valves, which are critical pieces of equipment. There's a lot of different sizes and types of control valves. Some of them, if they fail with mechanical failure, they'll completely shut down the operation, right? So we have digital valve controllers that connect to the control valve, and they make sure that the valve opens and closes according to where it's supposed to be. They also have really rich sensor information inside of them, and for the most part that data has been stranded. Sometimes it doesn't have the connectivity that you need. Often people aren't looking at it, and you may have had a guy that was really good at it and made it work, but then he got promoted or moved on, and so it's not very sustainable in general for our customers to develop that type of capability and expertise. We've developed a connected service for control valves where we can collect that sensor data and get that into hands of Emerson experts in our service centers that have years of experience. And the connectivity model leverages whatever infrastructure that our customers have. Often they have smart I/O that can talk digitally with the control valves, and we can collect it that way and then pass that data up, say through an OSI Pi architecture. In some cases, they don't have smart interfaces, so we can put a wireless transmitter on the valve and then communicate via wireless gateway and then send the data to the edge, to the Dell Edge gateway that then communicates to the cloud. One of the security features that we're developing right now is the capability to use what's called a data diode, which is a unidirectional firewall. And the basic idea is that you can connect two network components together with just a single piece of fiber rather than two pieces of fiber, and you can only physically communicate one way. It's like an air gap separation. That way you just collect the data on the OT side using OT protocols and the OT security that's already inherently in the system, and then publish the data through the unidirectional firewall to the Dell Edge gateway, which is on the IT side, and then that connects with bidirectional communications to the cloud through protocols like AMQP. So that's an example of the type of thing we're doing in refineries.
So can you talk about the actual decision makers or influencers who came to make a decision to use your methodology, valve controls, et cetera? Were you dealing with IT, operations side, product engineering?
Operations is the key stakeholder there. They know that they have reliability problems with certain types of equipment. They know what they're capable of doing themselves and how to deploy the technology and use it. They know in some cases there's asset classes where they don't have the capability and they're not able to support that in-house. Plus, Emerson is very focused. I mean, we're an industry-leading supplier of control valves. We have lots of domain expertise there. So not only we're using existing tools that have been around for a long time, we're also developing new tools to do predictive analytics, new types of time series data analysis and visualizations. Our customers aren't going to develop that themselves. They're busy focused on their process.
Or your embedded designers, software and hardware coming to the table and designing a system for them, because all those valves are small, medium, large, different places, hard to reach. Who is doing the embedded design and actually architecting what the module looks like, where it goes?
Sure. So that's a good question. Who's doing the design for lots of different control valves? You know, I just saw a picture of an 8-inch control valve that was going into a refinery the other day on Twitter. One of our service techs posted that online. It's a huge valve, and it still has the same small little valve controller on it. They're big pieces of equipment, but compared to that big control valve, it's pretty small. Those digital valve controllers are pretty standard, and the data that we can collect off of them is the same, regardless of the valve side. It's more about how you interpret the data and having the information about that piece of equipment and the capability for our experts to make sense of it, and as well as that flexible analytics that will then take into consideration the valve size and the valve operation. The technology that we're using for valve controllers, it's been around for a long time. The technology to connect to it via HART, wireless HART, field bus, those are also pretty mature technologies now. It's really about the analytics capabilities and connecting the data to the experts and to the cloud-based analytics. It's new. That's really what the promise of IoT is, from my perspective, is the capability to get data out of a lot of the equipment that's already there. There's millions of these valve controllers supplied by Emerson and other vendors that are running in operations today. The data is just lost. Nobody's looking at it, and that's the big opportunity for us.
Speaking on the data, and a few comments that have been made there about all the different types of hardware, and then 450 different platforms. One of the biggest problems I see there is there's a barrier of data sharing. 450 platforms means 400 different protocols. 450 different players means 450 different ways to transmit temperature from a sensor on a network. What's happening in that domain? Where I work in agriculture standards, and so we have that problem in ag. We're trying to develop the standards that allow machinery to share data, and it's a nightmare problem. And it's 1/1000 smaller than the IoT problem. So what are you guys doing in that domain?
So we're really looking at two type of protocol domains. The first is the OT protocols, and there's a wide variety of OT protocols. If you look at the industry at large, right? I mean, there's lots of different protocols. In the process industries like refining, chemicals, oil and gas, and so on, there's only really a handful that are being used, and they all have kind of specific purposes, whether it's digital communications over an analog signal. There's HART communications for that. There's Foundation Field Bus for purely digital communications, and a few other field bus technologies. There's wireless standards that are, IEEE communication standards.
I'm more worried about the protocol itself, like how you package the data, so that your competitor can make a valve to replace yours.
Well, we wouldn't want to do that.
Of course, that's where I'm at. That's part of the problem. Like,
no, but actually, no. I'd say Emerson, and the industry has been along the automation industries where we play. Actually, we've done a good job of developing standard open protocols that everybody plays pretty fairly in, and we come together in industry standards committees, and we've been doing that fairly well. In the OT space. In the IT space, there's really what we're looking at is JSON messages over AMQP and MQTT, or RESTful API interfaces, and that's really kind of the standard direction that we're moving, and it seems like most people are moving in that way, so that you can then deploy microservices in the modern IT infrastructures, and we're developing apps that we expect can be deployed in Microsoft Azure, in AWS, in our customers' data centers, in gateways, in Predicts, in whatever platform there is, as long as those platforms are providing the infrastructure for hosting virtual machines or containers.
Is there an organization that's formed yet around the idea of standardization of the data?
There's a lot of them.
Yeah.
There's
quite a few.
There's a lot, and I think you'll see them converge and merge. But the other thing is that there are still so many different use cases that you still need a lot of these other standards. So you're not going to reduce them down to one, but it's that's one. And I think the other problem that we see that we're solving or will be solving is everyone's when the OT meets the IT on a gateway, everyone's rewriting the same drivers time and time again.
Yeah.
Everyone's protocol is slightly different, and then you've got to have that talk to maybe your CEP. You've got that talk to your security module, and they're creating very monolithic images on the gateway, which is sort of slowing it down. And there's a lot of waste in the industry. We've got some really good ideas that we'll share over the next 6 months about how to make that way more open. Just the interoperability between all of these things, even if you have multiple standards.
Yeah, a good example is, OPC is a pretty common systems-based technology for communicating process data. OPC with Microsoft, they've released a technology called OPC Publisher that you can take OPC data and publish it to AMQP. But I don't need just OPC data. I also need hard IP and Modbus and what other connectivity protocols that I need. So having just one of these, it's too messy, right? So that's going to be, a challenge for the industry, is all of these disparate types of connectivity. I don't want to develop a platform to do that. Our focus at Emerson is on the industrial networks and the sensing technology on the OT space and the application software to deliver the value. And we see all of the infrastructure in between as part of the partnered ecosystem.
I think there's a long history of people just trying to protect proprietary protocols, lose out in the end, right? You got to have way more value than that.
Doing it today.
Yeah, but
it seems like they're losing.
Well, I think
they should.
But I think on the IT side, it's happened over the last 20 years, and so hopefully there's a kin between the two markets as they converge. You got to look for value above that, right? I mean, Emerson's value is in their expertise.
We have to go through a transformation to
get
there.
Yeah, and I think we're going through it right now. There's so many of these bodies coming together, trying to figure out fewer standards but more open. That it's sort of happening now.
We might be ahead in the agricultural industry in that we've got a lot of data, tremendous amounts of it, and we have this big problem in that it's who owns it.
Yeah.
And the owners of it are the people who created the data effectively, the farmers, the growers, and they want control. They want access to it. They want control of it. They don't want anybody else to have access to it. And if it's valuable, they want to be paid for it. So we spend a huge amount of our bandwidth trying to figure out how to control access to the data, enable access for third parties, create a standard so that third parties, because if you want to gain better yield, for example, on a crop, you need to be able to identify what happened with this particular crop, compare it to all the others in that domain, in that area, and figure out which guy was doing the best job. Well, you can't do that if the data isn't in some kind of common format, so a third party can walk in and do the analytics on the data to say, here's an output we got, a result we got. If you plant seed, at this temperature, you get a 3% yield improvement.
And I think you can solve the data normalization issue and still have the issue, because the competitive value is derived from owning that data, right? So I think there's two issues there. One is, how do I continue to normalize data? That's going to happen. Having open access to the data so everyone can farm it, excuse the pun, right. I think that's the bigger challenge, because people are going to see that as the competitive advantage.
Yeah.
The data has inherent, monetary value now, more so than the actual asset itself. That's where again, I mean, Dell's not going to solve that problem. I think other communities have to come together to solve, democracy of data.
Yeah, the fundamental problem is that one person's data isn't valuable.
Yeah.
Thousands of people's data combined is valuable.
Yep.
And so, but those people don't want to share that data. In the commercial game, it might not be so bad, but in the consumer game, it's going to happen too. I don't want to share my air conditioning operational data with anybody else, so they can market filters to me.
Yeah.
I don't want to see that.
Yeah.
So that's not me personally, but just as a general rule.
Yeah.
How you get around those problems and how you manage it requires data standards for how you do management of the data. You're going to have a way for the homeowner to say, I approve Emerson's analysis, to look at my data.
We all said we don't want to be tracked when we're carrying cell phones with us into the bathroom.
Yeah. Well, I think there's going to have to be some way where you can say, I'm okay with it, in the end, for everybody to be happy. It's what we have with the growers in the agricultural community. They have to agree that it's okay. So we collect their data and we give them access control to it. They can control who has access to it.
Yeah.
And they can remove that access anytime they want. So if they believe they're getting value in return for allowing the access, then everybody's happy. And, but if you just say, I'm sorry, we're going to send your data to Monsanto, they'll show up at your building and burn it down.
Are we good on time? One more question? All right. Sorry. Anyone else have another question? Yeah, in the back.
I wanted to go back to those two challenges that you highlighted. So there was security and then business case. cybersecurity one wasn't a surprise, but the business case, I want to ask about that because is the objection that I don't think it's worth it, or do they understand the value and they still say no? In other words, if you get a chance to get in front of somebody, really, to both of you guys, and make the pitch, hey man, I can come into your factory and I can do some stuff with your data coming off of your equipment, and I can use that data to show you how to save 3%. And here's some historical cases that prove it. What do you say? Why does someone say no?
That's a really good question. We sometimes
These statistics right here.
Yeah, I know. I mean,
you know,
there's numbers and there's statistics. It's funny because we have some really proven solutions that clearly can deliver improved cash flow. And our customers, sometimes when we talk about them, they nod their heads and say, yeah, absolutely, we know this is a problem. Come back, next 6 months. We don't have the budget we haven't put this in our budget, our operating budget for this year. Sometimes you're competing against other capital projects. So if we're trying to sell our customers a solution that can save them, say, $6 million a year, surprisingly in a refinery, they have other projects at hand on the capital plan that can save them a lot more in terms of top line throughput or reduced costs and optimization. So it's a challenge. Sometimes it's about talking to the right stakeholders because people see risk in terms of the Internet of Things, and if you're talking to OT focused individuals, often they see challenges working with IT to get the support that they need to leverage the connectivity. And even if there's a clear, compelling business case, they don't feel that they can use that properly within the organization. So there's organizational dynamics, there's company culture, there's competing investments and spending and budgets and allocations. I mean, there's cases where, man, everybody was on board and then they realized they didn't have the budget in place. And all right, well, here's 9 months in delay. Meanwhile, they're clearly just burning cash because we have a solution that can deliver savings today, but organizationally, they're not able to adopt it. Yeah, it's just, and in the industry space, it's somewhat conservative and slow moving. So there's committees and processes to manage risk, which is good. I mean, if you're talking about some of these industrial environments, there's a lot of safety concerns and cybersecurity concerns that they need to address and make sure that they're managing their risk in the appropriate way. Because if they have big process upsets, that can lead to safety risk, right? So there's reasons why the organizations sometimes are slower to move than we might expect.
Yeah. I'd say there's two other things. One is, in many cases, it's you gotta spend to save, and is what you're saying. The budget, it's like, hey, spend this and you'll save that. And so often the CFO is asking, what's the return on investment timeline? Is it 12 months? Is it 18 months? And if you're a publicly trading company, you could have all the pressures of Wall Street. Dell doesn't have that problem, luckily, because we're a private company. But we've got to go convince Michael, and then it gets done. But that's one of them. It's a lot of it is a spend to save equation, and a lot of CFOs are leery of those types of investment profiles. That's why we use case studies. We use these reference architecture designs. We say, hey, we've done it before. The second is, there's definitely this show me before I go and invest big time. So we've never done any deployment without a pretty big proof of concept or pilot, whatever you want to call it, up front. And then people are busy. So it's like, it's usually tagged on to someone's day job, right? They form a team, go prove it out, but deliver everything else you have to deliver in your daily life. And that's another one. And then I'm racking my brain at 8 o'clock at night to think of a specific example here, but there's sometimes the person deploying isn't the person seeing the benefit, right? So you go deploy this and you go to the operations people and you say, hey, you know, I want to make your factory more efficient with this, you know, this use case. And they're the people whose jobs and livelihoods are based on that process, and now you're telling them to radically re-engineer that process and take them out of the loop, and the data's going to go somewhere else, and, you know, off-site. It's a cultural thing. It's like, one, that's my job. Two, I like my job. Three, I don't trust the people, you know, who's going to take over my job. So there's a lot of where do you sell? You know, how do you position the solution and to who? And then what are the cultural impacts and the business process re-engineering around that have to go and happen?
Yeah, in the case of reliability improvements, some of our customers have really good financial models to take credit for the prevention of unplanned shutdowns or you know, unplanned maintenance outages. Some of our customers don't. Okay, and what we found is in those cases they can take a business model and say, look, we're going to reduce our maintenance cost or reduce our unplanned outages, and the finance guys will say, well, you can't take credit for eliminating things that don't happen. So instead we'll kind of move the model to justify the investment based on reduced maintenance costs, something that we can quantify and measure. And meanwhile, the real justification is improved reliability. And so we are taking that method as well for a service for steam trap monitoring that we offer, rather than quantifying the reliability or product quality improvements that we deliver. We'll build the case on energy savings and then deliver on energy savings and the reliability and quality.
I think, sorry to interrupt quickly, that's why you're seeing the emergence of this new role in certain companies called the Chief Digital Officer. You know, you've sort of got the CIO who's fast becoming in forward-thinking companies the Chief Digital Officer. And we've seen that in a handful of our accounts that were struggling, and then the CIO changed titles and all of a sudden things started to move because they got a mandate from the CEO, said, hey, you control more than just the IT portion of this. You're going to go and radically change the business model. And then they sort of had a boardroom remit to go make it happen. And it's to avoid some of these things like, well, I don't measure it that way, or you know, that's not my problem, it's someone else's problem in another part of my company and I don't care about it. Well, a Chief Digital Officer can span, you know, all of these types of functions and then drive these projects into their organization.
Just quick follow-up. So on the issue of the cultural issue, so right, I'm the guy who runs the factory, but say the company's four. You know, maybe sort of uncool, but what's in it for me if I make my factory more efficient? What's in it for my people? Does that come up?
Yeah.
Yeah, I'd say people have to be metriced and compensated based on those types of improvements. And yeah, some people will have career, you know, objectives that will drive them to do things, or they'll have business objectives, performance objectives that are handed to them, and these types of solutions will help them reach those objectives, right? Yeah.
Great. Perfect. Well, that was the last question we have time for. One more? Can we do one more? All right, let's do it.
I'm curious on this discussion. So what's the effect of the sales cycle? Is that increasing? Is it increasing?
Yeah, it's a good question. The question is, what's the impact on the sales cycle? If we're selling connected services, for example, it generally has a longer sales cycle than if we're selling a transmitter, right? And in a lot of cases, our customers and our standard sales model is based on our customers knowing they need to buy a piece of equipment from Emerson, and they call us up and they send us a purchase order, and we deliver the product with an invoice, and we can help them install it and support it and everything else, right? This is a different type of sales model where they may not even be aware of the demand. They know that they have problems, and they don't know that there are solutions that can help them solve those problems. And if we have focused solutions, I've had meetings with customers where I'm not selling them on the idea. They're telling us about all these problems that they have, not yet aware of our solutions or our capabilities. And once we match up our capabilities with their problems, you know, at the end of the conversation, they're asking for proposals. So I think rather than a boil the ocean type of architectural approach to say, hey, we can solve all the problems in your refining universe or petrochemical universe. Instead, we're really developing very focused solutions to specific problems that we can match up with our customers' needs. And we're getting a lot of traction that way, rather than building a generic, we could do anything for you type of IoT vision. Generally that doesn't work because people don't know what to buy.
Yeah, definitely. Much longer sales cycles, and I use this word, everyone is a snowflake, and so if you look at a snowflake falling, they all look the same until you put it under a microscope, and they're all completely different. And it's because every customer's things are slightly different, even in the chemical plants. You look at building management, everyone has different HVAC to lighting to whatever you're hooking up. So it looks like building management until you go and engage with that specific company, and then their things are different. That's one part of the snowflake. The other part of the snowflake is, in some cases IT's in the driving seat, in some case it's operations, in some case it's the CMO office that's driving the change. And so that sort of elongates the sales cycle as well, because you have to figure out each time who is your customer. It's not like doing an Exchange migration for 10,000 users that the blueprint is the same every time. There are set blueprints, but they need a lot more customization to fit it into each of those customers. Once you win one, they're relatively sticky because the deployments are sort of long and hard. But we've had to at Dell think differently about our sales force, think differently about our compensation schemes, think differently about how we go to market.
You're talking sales folks. You're talking segmentation of your market and proposing value based on
Exactly.
Good marketing strategy.
Exactly.
Yeah.
That's exactly what it is.
Yeah.
Great. Well, thank you very much, Mike. Andy?
Thanks.
It was a great discussion. We'll give you a hand.
Appreciate it. Thanks.